Okay, let's continue our history of the universe, and now we are up to 380,000 years after the Big Bang. So notice this is a pretty big jump, going from 3 minutes to 380,000 years. Notice this is a pretty big jump, going from 1 billion Kelvin to a temperature of 3,000 Kelvin. And notice that this is a pretty big jump, going from 10 to the 46th meters across to 10 to the 48th meters across. So there's been a big gap in time, but we can ignore all of that time period, and we're going to concentrate on what happens next. So look at what the universe was composed of. So it was composed of nucleuses and then neutrons and electrons, but notice now what has happened. Now there are atoms. So the temperature of the universe has decreased enough that electrons have attached to the nucleuses, the nuclei, to make the first atoms. Now, why is this important? Because now you've got atomic hotels. So when we talked about the atomic hotel, we said that there were energy levels on which the electrons lived. And then what did we say would happen if one of these electrons were to jump? So if this electron was to jump up to this energy level, it would absorb energy, and then when it jumps back down, it emits energy. What did it do? It emitted the energy in the form of visible light. So this is the birth of not only the first atoms in the universe, but it's also the birth of the first visible light in the universe. So how do we know that this happened? So back in 1963, Bell Labs, AT&T, was investigating radio communications, and they built a receiver. So they were doing work on these new-founded things called a cell phone, and they wanted to be able to communicate using radio waves from one person to the next. So in order to do this, they first had to build something that would catch radio waves. And they were inadvertently building the first radio telescope when they did this. And so just on a whim, they took this thing that caught radio waves and they pointed it up into the sky. And then what they found was they were receiving radio communications from outer space, radio waves from outer space. At first, they thought that it was aliens trying to communicate with us using radio waves, but again, it was a very boring conversation. So they then realized that there were certain pockets in the sky that were more dense than others. And so what this represents is these radio waves originated as visible light. So you should know that visible light has a very short wavelength. Okay, but imagine that you take a balloon and you put a squiggly line on it, and then you blow up the balloon. So that when you blow up the balloon, this squiggly line now looks like this. It has been expanded. So if this is visible light that has a small wavelength, what is this thing that has the large wavelength? That's a radio wave. So originally, when the first atoms began to produce light, they produced visible light. But because the universe has been expanding ever since, those light waves have been expanded and they've been turned into radio waves. And then when they mapped it, they got that picture there at the very side. To the right is a picture of where the radio waves are the most concentrated and where the radio waves are not so concentrated. And it gives us an idea of the temperature of the universe. So those yellow areas are areas that are hotter, and then the blue areas are areas that are cooler. So someone had the idea of what would happen if you took the radio wave map that they just made and turn it into a visible map. So they took the radio waves and they scrunched them back up, turned them into visible light again, generated that picture, and that's a snapshot of what the universe looked like 380,000 years after its formation. So that is pretty cool. So that's the oldest photograph in existence. Okay, let's take a break, and when we come back, we will continue talking about the buildup of the universe.